So I said stern tube. Stern tube means I have one cylindrical cylinder and my tail shaft is passing through this, and my propeller is here. Okay, so propeller hub, sometimes they say boss. Okay, this is propeller blade and this is your tail shaft. Tail shaft. Now this stern tube will have sealing arrangement here. Seal, actually it will allow rotational motion, but it will not allow liquid or gas to pass inside or outside. So this is seal, this is called forward seal, this aft seal. Okay, now inside there will be lubricant. Okay, now seal and lubricant will not work, you must have bearing also. Okay, so because sealing lubrication purpose is to save your bearing, so the bearing can withstand load and the system can run longer time. Stern tube bearing supports the tail shaft, and the propeller's weight act as a gland to prevent seawater from entering the machinery space. So seawater, if it is entering into machinery space, that means this corrosive fluid is going into your machinery area. It will be much more complex if water is going there. So because there will be lots of oil and lubricating oil and other things, so you cannot put seawater there. So the seals will be preventing this one. Material like lignum vitae are lubricated by seawater, while modern design employ oil lubrication with a white metal line stern tube bearing. So lots of material science research is going on to replace this lignum vitae or other type of material. So for example, white metal is being used these days. Oil lubricated white metal bearing, normally this alloy of white metal, this one is alloy of antimony, tin, lead and cadmium, bismuth and zinc. Okay, so using this one they make white metal. So bearing, normally it will be cast iron based metal, bearing metal. Normally cast iron based will be there, while lining, inside lining will be white metal. Okay, so cast iron will be protected by your white metal. So this is sliding bearing or journal bearing. This you can see, this one shaft is shaft can be going inside, and outside one you can fix. Okay, now this bearing is sliding bearing, like one, there is no rolling element, on rolling ball bearing or roller, the shaft will be sliding inside. Okay, so this is called sliding bearing, carries radial load. So this is sliding bearing or sleeve bearing or journal bearing. This is called journal bearing or muff bearing, and it is carrying radial load. There is no axial thrust load taking capability here, only radial load it will take, because your propeller will be hanging. Okay, because hanging and seawater will try to enter into a machinery area, so that thing it will prevent that water injection into your machinery area or oil going out to your water, and propeller load or shaft load will be held by this bearing. So normally it will be oil lubricated, a thin film bearing will be created, film of oil soaks the sliding surface. Okay, so thin film will be reducing friction. So friction reducing means life will be longer. At higher shaft speed, a thin film oil is created. So this principle is called hydrodynamic lubrication. Hydrodynamic lubrication. Okay, to reduce friction and wear, to reduce friction and wear, viscosity of lubricant will be important. Viscosity of lubricant is very important. Lubricant, shaft speed, bearing load and bearing dimension. Bearing dimension means smaller diameter cannot carry very high load, but larger diameter can carry very high load. So, to have a good lubrication and to reduce friction and wear, viscosity should be higher and shaft speed should be lower. Higher speed means higher surface friction, means higher temperature generation. So, lower shaft speed better. But in the certain cases your speed is the main parameter, so you cannot control. So, in that case you can control other parameter, viscosity and hydrodynamic lubrication or material or other parameter. Okay. Bearing load, how much load it is carrying, and bearing dimension, this is the main factor. So, stern tube seal. A stern tube is a welded ship's hull. So, shaft propels the propeller. The shaft propels the propeller and transmit its thrust to the hull. Journal bearing supports the shaft propeller. So, here journal bearing you are giving, you see right side picture, top left corner, you have journal bearing or stern tube bearing. So, to prevent lubricant leakage, rotate lip seal. Lip seal means like one face is here, another face is here. So, you can put certain amount of seal, okay, so that fluid will not be leaking. So, that is called lip seal. It can be used. Sealing rings at each end of the stern tube constitute a vital barrier between lubricant. So, there will be a sealing, there will be another sealing. So, both end will be sealed and inside there will be lubricant. It will be saving your system. So, stern tube seal function, it will be ensuring water, oil, water does not enter into engine area and oil does not go out. Oil does not go out. So, oil lubricated stern tube has two types of seals: water oil seal, and another is inboard end. Inboard end seal. So, water oil seal is nearby water, so water should not enter. Another is other end of the seal will have inboard end seal. So, two types of seal. Two types is used. A few major stern tube seals are leverin seal, mechanical phase seal. Major stern tube seals, leverin seal, seals, series of barriers, series of barriers means like one seal is here, another seal is here, another seal is here. So, pressure changes from one seal to another seal. So, that way they prevent leakage. Mechanical phase seal, and packing seal. Okay. So, mechanical phase means two surfaces there, one surface, another surface, in between you put some seal, so that fluid will not be leaking through this. Okay, this is called phase seal. Another is packing seal. Packing seal means like one rotor is there, and you put lots of rope, of cotton rope with grease coated, and that will be creating a long seal. That is a mechanical packing seal. So that also will be preventing your leakage. In many engines, it is very used to very common to use in normal application, this packing seal, because any people will take one cotton rope and put some grease and use it. Okay. Intermediate like shafting. In general shafting, you say shaft components are forged steel, feature integral flange coupling. So flange coupling will be there. These are flange coupling. Flange coupling, like this is one shaft and this is one end. Another shaft will have like this. Okay. So those now you put two holes, put nut bolt here. Okay, here also to put nut bolt, and in circular pattern, if I draw this one, it will be looking like this. Several nut bolts will be there. Okay, you connect to one shaft is here, one flange is here, another shaft is here, flange is there. Put together front by front, make a hole here, like this. Nut here, and put nut and bolt. One bolt is there and nut you put here. Okay, then whenever this shaft is rotating, this shaft also will be rotating, because this is many nut bolt will be connected, maybe 5 6. Okay. So normally this is a very common connecting mechanism, and this will be giving some flexibility also for the shaft to move. Little bit movement, lateral or axial motion is misalignment is there. This can hold it. The taper end is threaded, accommodate nut. Okay, taper end means this propeller end is called taper end. So taper end, like you put propeller, put one big nut. Okay, it's a pilgrim nut. So that way you fix your propeller, and so propeller is connected to your tail shaft. Then there will be intermediate shaft, 2-3 intermediate shafts will be there. There will be thrust shaft, then engine shaft. Okay. So now propeller shafts are made of using forging method. So what is forging? Means shaping metal using localized compressive force, often delivered with a hammer and die. Okay, made from single piece of metal, then machined to meet specific application requirement. Higher strength compared to welded or assembled shaft. So these are having higher strength. That's why people are producing using forging method. Marine shaft material. So marine shaft must be very strong. It's obvious, but all type of metal you cannot use, because marine water is very much corrosive. So corrosive environment, you cannot use mild steel. So you have to go for SS or stainless steel. So stainless steel also several grades are there. For example, one grade is SS316. So iron, chromium, nickel, molybdenum, silicon, many components mixed with the iron, and it is made SS316. So there are other type also, the 630, 316, 304, 303. So SS30, an austenitic stainless steel containing molybdenum to enhance corrosion resistance. SS304 shares similar mechanical properties but exhibits greater strength at elevated temperature. Good oxidation resistance at 870 degree centigrade. Austenitic steel contains a high percentage of nickel and chromium, good strength and for corrosion resistance. So normally this material property will be like this. Material property. Okay, tensile strength. Tensile 400 to 800 MPa, megapascal. Yield strength 200 to 700 MPa, within that range. Thus I am writing. Bending stress. Bending stress. Stress 180 to 400 MPa. Modulus of elasticity. Of elasticity 205 GPa. About. Shear modulus of elasticity. Of elasticity 83 GPa, gigapascal. Okay. So propeller mounting. When propeller is fixed on the shaft, So there will be certain mechanism for mounting. So propeller is attached to the tail shaft. A taper and key or keyless system can be used. So keyed system is there. Key system is large knob is secured onto the end of the tail shaft with a cone bolted over it to ensure the smooth water flow from the propeller. So water should not get resisted, so it should not get distracted too much. The propeller should pump properly. Keyless system, axial and circumferential grooves are machined into propeller bore, allowing high pressure oil to be injected between the tail shaft and propeller. Another option is a pilgrim nut. So at the end you put on a big nut and that will be holding the propeller. It will be provided a frictional grip between the propeller and shaft. It is screwed onto the tail shaft with a steel ring receiving thrust from a hydraulically pressurized rubber tire. This thrust forces the propeller into tapered tail shaft, allowing engine torque transmission without loading the key. So classification of ship propulsion system already we discussed, but again you see this is a naval propulsion system. On big geared system, engine speed is very high, so you need to gear to reduce the speed. If engine speed lower, then gearless system also possible. Very high, for example, gas turbine engine, diesel engine, those will have higher RPM, engine shaft RPM. So in that case, you have to reduce speed using gear. So combined gas and diesel power cycle, diesel electric gas, those will have higher speed. So you need geared mechanism. And the gearless system can be possible. Low speed diesel engine is there. Directly you can connect engine shaft to your propeller shaft, or fully electrical. So electrical system is there. If using one variable frequency drive, you can control electrical frequency. That frequency will reduce your motor speed. That motor speed will be reducing further your propeller speed. So that way you can use geared system or gearless system. So here you can see some mechanical direct system or electrical system. Here in this picture you can see gas turbine system. So gas turbine system speed normally it will be higher. So higher gas turbine system you must go through one gear reducing system, then you connect to propeller. Okay. And if you have multiple engines supplying power to your propeller, so then you have diesel engine maybe. So diesel engine speed normally lower, so diesel engine speed will be increased, then it will be connected to your main gear system and you can transfer the power to your propeller. Next picture you can see gas turbine system is there, electrical system is there, so both speed may be higher. So in that case reduce gear reducer, then you transfer the power to your propeller. But in many cases like podded propeller, only electrical system is giving power. For example, battery operated system is coming these days. So in that case or engine is producing power, that power completely you produce electricity, then electricity you give to motor. So in that case motor can be running directly to your propeller. So there is also one mechanism. So the different mechanism will be there. One is basically I am discussing mechanical system to produce power, and mechanically it will be transferred to your propeller. Another way is that you can use electrical system or multiple power source, diesel engine, gas engine, gas turbine engine together, connect all together in a common gear system, then you send to propeller, or take main engine power, produce electricity, then motor will be running your propeller. So that way your ship can be propelled. So here some picture I have taken from Marine Insight, that website. So you can see here also like engines are here, marine diesel engine is here, some generator engine. So generator you can produce electricity, then same power you are transferring to propeller. In another case main switchboard is here, propulsion module is here, podded propeller. Okay, controllable pitch propeller. CPP means controllable pitch propeller. Controllable pitch. Okay, CPP. So using you can control pitch of the propeller so that your speed can be changed. Your thrust, amount of thrust you are giving to your ship can be changed. Maneuvering will be easier. So DC or AC motor or propulsion system motor runs propeller. A generator and prime mover assembly produce electricity. Traditionally employed in smaller vessel, efforts are going to use larger cargo vessel. Used in tugboats and trawlers, dredges, dynamic positioning vessel, cable lying ships, icebreakers, many applications are there. So I already told the shaft alignment is a big issue. Here one example is given. You can see this picture. If shaft is aligned properly, your motor or engine, your propeller is here, and completely aligned, there is no misalignment lateral or angular, then things are smooth, there is no vibration will be less, machine wear and tear will be less, and system will be running smoothly for longer period. But if you have lateral alignment, for example, your shaft A and shaft B are not in axis, okay, one shaft is here, another shaft is here, it is not in axis, okay. So, in that case it is rotating, but it will also be rotating, but there will be some vibration because of this misalignment. Another option, another is that instead of complete straight line, it may create some angle. So, if it is creating angle, again it is rotating, but it will try to rotate, there will be some problem. It will give extra load to your bearing, okay, or it will fail because of the vibration will be coming because of the angular thing, or actual misalignment also possible. For example, two shafts are here, you are targeting to keep almost zero gap, but because of misalignment you are giving longer gap or very smaller gap or forcing each other. So, that also will be a problem. So, maybe your misalignment will be combination of all these, or misalignment can be only one, okay. So, shaft alignment, aligning two or more shaft with each other within a tolerance margin. Shaft misalignment causes wear and damage to the system. So, types of misalignment: offset. Offset means center line both of shaft are parallel, okay. So, first one parallel or offset misalignment, second angular misalignment, this one, and another can be like axial misalignment, like distance. Misalignment can be parallel, angular or combined, okay. Now, if let us say I have one shaft here and another shaft is here, both are not in axis, their axis are not matching. So, what will happen, like I have one bearing here, right, and I have another bearing, because bearing I set properly, but one shaft because of certain reason it got misaligned. So, this, when one shaft is rotating, another shaft will also rotate on the same axis. So, it will happen, extra load will be coming on the bearing and vibration will start. So, when vibration starts, so vibration will be again, it will be multiplying. So, finally whole system will fail. So, before starting your machine, first you have to check your critical speed, your alignment properly, then you can run your system, okay. Shaft misalignment. So, is a major contributor to rotating machinery failure. Okay, and misalignment increases failure. Misalignment increases failure. Increases failure, not friction, you can say. Friction, so energy consumption will be increasing. So, energy consumption increasing means heat generation will be higher, second system can fail. So, premature bearing seal failure. And seal failure. Excessive seal lubrication leakage. Lubrication in seal. Leakage because seal will be wearing out quickly. Failure of coupling. And bolt, any joint connection, coupling, they will fail. Increasing vibration noise. Okay, this sort of problem can be coming if system is misaligned and not handled properly. Thank you very much for today's lecture. Tomorrow we will start new topic. Thank you.